we are going to do an absolute motion analysis. And what is this all about is like, let's look at the question first, okay? Let's look at the question first. It's not that bad. Once you can do vibration, all these are really easy, I think. Okay. Right. So we're going to solve a problem like what you see over here. So what you will have is the bar DC. This, by the way, is on your avenue to learn. Bar DC rotates uniformly about the shaft at point D. Where's point D? So point D is here with a constant velocity of omega. So constant velocity, dictate that alpha is equal to 0. Determine the velocity and acceleration of the bar AB, which is confined by the guides to move vertically or to move vertically. So this guide will get the system to move vertically. So this is what we call an absolute motion analysis. Okay. So in terms of math, have you finished learning how to solve your differential equation yet? Where are you now in 2Z03? Can someone tell me? Any idea? No? Okay. I'll find out later on, okay? So when a body is subjected to general plane motion, okay? So what do we mean by general plane motion? Okay, so general plane motion general plane motion undergoes a simultaneous or combination of translation and rotation. So if you look at the notes in, I think, week 4, right? If you look at the notes in, I think it's week 4. I can be wrong down here. Okay, we look at week 4. Is it week 4? Yeah, I think it's this one. No, maybe week 3. Go on. If you look into week 3, maybe it's a Friday. Can't remember now. Yeah. I put a cross down here. I'm sorry. I should not cross it out. Okay. So that is what general plane motion is all about. Okay. I remember I put a cross there. Then I said, no, it's good for them to learn. Okay. So we are going to go into general plane motion. Now, whatever we learn over here will be used in chapter 17, chapter 18, and chapter 19. Okay, don't like, okay, we learn from here everything, right? I can forget about it. No, we're going to use this again in chapter 17, 18, 19. For example, we need to find an acceleration, right, for a moving body. What force is it is it hitting on a different body system? Okay, go on. Okay. You can relate the motion of the leakage later. That's fantastic. Is it close copy or no? Okay, very good. Go. How many copy was those police? Don't worry. Unbelievable. Right. So from here, right, we are going to solve general motion analysis. So I'm going to give you the solution procedure. This topic has more math than any other things, okay? So we're going to locate a point. First thing we're going to do is we are going to locate a point. Okay, we're going to locate a point on the body using position. Okay, using position coordinate S. Okay, so S or S is measured from a fixed origin. Then after that, we're going to measure from a fixed reference line. Okay. The angular position theta. Okay. Then with that, the third thing that we're going to do is we are going to relate S to theta. Okay. So i.e. S is equal to a function of what? Theta. Okay. So this is the easy this is the easy part. The next part is where you guys are all the expert, okay, excluding me. So we we are going to do the time, okay, derivatives. Even I cannot pronounce the name properly. Okay, we're going to do the time derivatives. So what we are going to do is we are going to take the first derivative. I can't even spell that thing, you know, of S is equal to F as a function of theta with respect to time. To get the relationship between velocity and omega. Okay, so this is our linear velocity, and this will be your angular velocity. And then from here, good luck, Eugene. Take the second derivative. Time derivative. Oh, I think, yeah, second time derivative. To get the relationship between A and alpha. A being linear acceleration, and alpha given angular acceleration. And then finally, seriously, Eugene, the chain rule. You have any idea what's the chain rule? Hey? Yeah, so you know what's chain rule, right? I'm not freaking a clue what is this, okay? Okay, so you're going to use the chain rule. Yep. Yes, okay. The chain rule of calculus okay, must be applied okay. So are you all ready? It's not that bad, okay? I hope it's not that bad, okay? So we're going to look at this question again. I'm going to start. Now, it's important for us to do up to the acceleration because any motion, you know when you use the what? A force. The only way to determine the force is by using Newton's second law, which is equal to 1. F is equal to 1 and A. Okay. So we use this force later on. I will integrate. I'm thinking of integrating Q04 with 3A03. By the way, 3A03, you guys cannot see, 3A03 has been approved by the provost to be 3A04. Okay. So you guys will not see this at all. As the next generation will see the following things. Okay, you guys will see. But anyway, so we are going to link it. We have to go up to the acceleration because from the acceleration we can calculate the what? The force. Yes or no? Velocity is absolutely what? Yes or no? It's just velocity. We cannot get what? Force from velocity. Okay, I mean you need to integrate. Okay. So let's look at this. Let's look at the first problem now, okay? So we did not look enough of the first problem, so I'm going to copy. Okay, now, looking at this for the first time, it can be a bit overwhelming. I repeat again, you okay? Okay, looking at this for the first time is a little bit overwhelming. Yes or no? It's normal. Okay, if you stare at this crap for 3 weeks, you find it real easy. Now we look at it, oh crap. Yes or no? Okay, so be patient. Okay, learn with a happy attitude. Okay, don't be like me. I don't learn with happy attitude, only sometimes. So the first thing we do, a bar DC rotates uniformly about the shaft at D. Okay, so you realize that this is rotating. Yes or no? This thing is rotating. Determine the velocity and acceleration of the bar AB. So this is the bar AB. Okay, which is confined by the guides to move vertically. So we know that AB, the motion is up or down? Yes or no? Right? So we have to know